Now, in this panel, future panel, the ESTHub Vision Day 2021 has reached to his culmination. In this panel, we will discuss remote sensing in Estonia and Latvia and Lithuania in general and in broader sense. And at first, our first speaker will describe a situation in Norway when where these land cover studies are have much more technical difficulties than these examples we had covered earlier. So Floris from Norway, the floor is yours.
Thank you very much, and thank you for inviting me. I'll try and share my screen. Not sure if you're...
Your first slide is visible.
It's visible, thank you. Yeah, thank you very much for inviting me. And thank you for the nice words. I hope I can fulfill your expectations. I'm going to talk about nature mapping in Norway. And my name is Floris. I'm not Norwegian, I come from the Netherlands, but I've been living in Norway for the last 15 years. And I work in a company called Blom, and we're a company working with mapping, aerial photography, and remote sensing. And I'm heading the remote sensing department. So now we're going to talk about nature mapping in Norway. Why are we going to do nature mapping in Norway? And there's actually very good reasons for it. There's three main threats to biodiversity. One is climate change, the other one is pollution, and the third and maybe the most important one is habitat loss, here illustrated in tropical areas in Brazil. Norway is using a lot of effort and money on that, but also closer to home in Norway, we have our difficulties. So we're losing quite a lot of habitats in mountain areas due to wind energy, hydropower, and general infrastructure. And the last one is a typical Norwegian, maybe, is cabin. So there's almost 500,000 cabins in Norway, and they are building and building all the time. So there's lots of habitat loss. And they try to monitor it, and they see on these different mapping operations that the amount of undisturbed nature is decreasing over time. And nobody really knows the exact rate, but the direction is very certain. There will be less and less undisturbed nature. So what can we do about it? If you want to do something about it, you have to map the things you have, otherwise you cannot take any action. So how is nature mapping done today in Norway? The Norwegian Environmental Agency is responsible. They've spent lots of years of creating a new framework called Nature in Norway, NIN. It's a system for categorizing nature. And it's very detailed. They have lots of types and subtypes. It's a field-based mapping, and it's 1 to 5,000 scale. So for a field-based and manual map, it's quite detailed. So they have to prioritize. They do this mapping only on potential development site and only on areas where they expect to find endangered nature types. So things they have to take care of. So the result is actually that only 3% of Norway's land area is mapped according to this NIN system. Roughly 1% per year. They have older maps with different systems, but the NIN system is from 2015 and got established then. So they actually have no idea wall to wall what they have in the country. Wall to wall mapping is lacking. So the big question is, can we get any help from above? And this is also something that the Norwegian Environmental Agency has been wondering for a longer time. They are perfectly aware of the fact that NIN field mapping will never reach 100% coverage. It's too slow and too expensive. So can we use remote sensing and artificial intelligence to make wall-to-wall maps of nature types faster? There was 2 years ago was a tender for finding out if we could do this, and we answered yes, we can. We're a bit optimistic. So our idea was to use this Nature in Norway system on the left-hand side and good remote sensing data on the right-hand side, use some processing, machine learning, and ecological knowledge, so we can create automatic nature maps automatically. A little bit about nature in Norway. I'm not an ecologist, so I don't know a lot about this. Everything is in Norwegian, so it's also a bit hard to understand. But the main things I want you to know is that it's a very thorough typification and description system of ecosystems. It's multi-scale, so it can work on landscape level and down to different specific habitats. And it's a hierarchical, so that's very important. So we have main levels, the main level of systems, land system, wetland systems, sea systems, freshwater systems. If we go into one of these, the land systems, you have a whole different level with subsystems. These are called main nature types, 45 of them, covering the whole of Norway. Some of them are easy. Some of them are easy, like bare rock. Some of them are very difficult with very cryptical names. That's not so important if we go into one, which is called in Norwegian snøleie, areas hindered by long snow coverage during the season in the mountains. We have, again, a lot of subsystems that are defined by several variables, gradients. So one of them is the amount of snow coverage over time, hindering the growth of vegetation. And another one is calcium content, which defines the type of vegetation that there are. And there's a third one is the occurrence of water during the summer. So it's very complicated, but the good thing is you don't need to solve everything. So we are never going to solve all of them in one go, but as long as you can solve some of them and you stick to the categories, then you can solve a part of the puzzle. So we were still optimistic, but we have to find out how we're going to do this. Luckily, we have good remote sensing data. So there's more and more available. And that's also the topic of today here in Estonia, of course. So we have data from satellites, airplanes, drones. But we had to focus on data that's nationwide available. So there was no option to use, for example, drone data, make a fantastic solution, and then not able to scale it up to the whole country. So that was one of the requirements in the assignments. Luckily, there's almost complete LiDAR data on Norway now. Some parts are still missing, but almost the whole country is scanned. It's a quite large country. We have aerial imagery and we have Sentinel-2 satellite data. All of them are important. The LiDAR data is taken by airplanes, like I said, covering almost the whole of Norway. It's point clouds, so it's points with coordinates X, Y, and Z, approximately 2 to 5 points per square meter. And it contains information about terrain, of course, and also the surface features, trees, houses, and so on. And it's open data. Just to show you how much content there is in LiDAR data, this is a classified point class where the class colors are showing the tree heights. So this is not the way we use the data in this project, but it's just to show you there's lots of information about terrain, vegetation in the LiDAR data. Here you also see a similar visualization from the top, and there you see both terrain types, vegetation types already in the LiDAR data, which is really good. Going to aerial imagery, the whole of Norway is photographed every 5th year in a fixed program, 25 centimeter resolution, normal RGB imagery, and for the later projects, the newer projects, also near infrared. So here you see some aerial images, just to show you what it looks like. Going to Sentinel, we already heard quite a lot about it today, so I only focus on what's important for this project. We're using Sentinel-2, the optical satellite. There are 2 identical satellites. They pass over every 2nd to every 5th day, depending on where you are in the country. And here you see these strips. Norway is very lucky with its layouts, north-south, so you get a lot of data in one pass. It's 10-meter resolutions for 4 bands and 20 for 6 bands. We need both of them. So why are we actually using Sentinel-2? It's already been a topic today, when we have this very nice aerial imagery. So you see a lot more on the aerial imagery, and Sentinel-2 never shows all the detail. The answer is, of course, like we heard before, is the time. You don't get any time series during a season or over several years with aerial imagery because it's not being flown. It's too difficult and it's too expensive. So Sentinel-2 has observations of the same pixel over time. And that's very important to remember. So our strategy is to use the best qualities of each remote sensing data set. So from the LiDAR, we can actually see tree or forest mapping and terrain forms. Aerial imagery is very good for showing detail and mosaic-like structure in the nature. And Sentinel-2 has the dynamics of vegetation during the season. And it's also a very good data set because it can be calibrated and the reflectance values are easier to use than for aerial imagery. Some examples. So what are we making from the LiDAR data? We make a lot of what we call map layers. So we derive the terrain model, and from that we derive things like slope map, position index, which tells you something about whether you're exposed as an area or hidden in the landscape on different scale levels. And we have depth to water indexes saying something about potential soil moisture or wetness, solar radiation, vegetation height, roughness, and many more. So we create those from the LiDAR data. From the aerial imagery, we do 2 things. We make a segmentation where we combine pixels into small homogeneous objects that we're going to classify later. So they are our basic mapping unit. We also use semantic segmentation or a deep learning classification to pick out the simple area type. So we're not going to try to classify all the nature types by aerial imagery, but we try to pick out water, bare rocks, stones and shadow areas because they are very easy to spot and harder to spot in Sentinel. And Sentinel-2, we do 2 things. So we process single scenes. We have cloud masks and snow masks, and we generate vegetation indexes, wetness indexes, and different statistics per scene. And then we put all the scenes in a stack, in a time series, and we extract statistics out of the time stack. So for example, for a pixel, what is the maximum NDVI that the pixel got? We don't care which time it is in the season or when, but we just want to have the maximum or the average or the minimum. And another thing is we have a calendar day for snow melting for each pixel. Derived from a couple of years of Sentinel. We put all those map layers into a machine learning algorithm. We tested a couple of ones. We're testing a few now also. I can get back to that later. And we put all the data layers from the LiDAR, the aerial imagery, and the satellite at different resolutions in these algorithms. But we're lacking something. We need reference data to know what is what. So there we have ecological competence. That's not us in Blom, but we cooperate with a company called Saler Natur. They are experts in the field on this NIN system, and they're vegetation ecologists. It's not so easy to sample. This is actually the image. The picture shows how not to do it. We don't want to look too closely. We want to have something that is a good example. So we need also the correct scale of something that we can see with our remote sensing data. Single species are not so important for us, but we need to have good representative samples over the whole area. So instead of looking for it on the ground, which is a lot of work, we looked it through image interpretation, and they use their field knowledge to do this work good and fast. We had the pilot area in the north and mountain areas, actually 2 pilot areas, but the main one is here in Stuefjord, Kåfjord. We focus only on the mountain areas. I might not have said that in the start, because this whole thing is not working so well in forest. We need to have a clear view of the vegetation. And we're mapping the nature on main nature type and try to get as many of those gradients and variables as possible. Just to show you, this is in Norwegian, sorry for that, but just to show you 3 main types. There are many more in reality, but the main ones that illustrate our method are exposed areas that are bare in winter and that are very rocky and exposed to wind. Nothing is growing there, which is T14. If you get out of there, you have this more lush heather vegetation in the mountains that is protected in the winter by snow, but has an early snow melting. And then we have T7, which are areas that are covered long in the season by snow. And then we have their environmental variables that accompany those main nature types. Like I said, we did photo interpretation to getting reference data. We know the ecologist noted everything there was to know. And we divided the data sets into training areas and validation areas, and we had a quick check in the field just to calibrate the people who were doing the interpretation. This is a bit messy, but overall we got quite good results, and that was really promising. At the same time, so we're getting accuracies close to 90%, and you can have a long discussion on what they mean and what kind of ways we measure the accuracy. We also see that some of the classes are behaving well. Those are easy to spot, and some of them have very low accuracy. They are hard to spot, or they are maybe badly defined in this NIN system. Main thing is that we reached a kind of optimum already after using 7 different data layers from Sentinel, LiDAR, and aerial imagery combined. More layers did not improve the results so much, and all the remote sensing types were necessary. Otherwise, we lost quite a lot of accuracy. I'm almost done, but I just wanted to show you a little bit what it looks like. The polygons are reference areas. They are quite large and they are quite homogeneous according to the ecologists. This is in the background an aerial image, and you see actually almost nothing. The data is really flat and quite hard to spot what is what. If you use a Hillshade based on the LiDAR data, it already makes a little bit more sense. You see the exposed areas are lying on tops of on ridges of the mountains. So for me, that's, as a non-ecologist, that's easier. If we see the topographic position index, which is white for exposed areas and going to brown, yellow, blue for hidden areas, makes a lot of sense. And here we see the calendar day of snow melting. Green is very early in the season. Blue is almost the whole season, growing season, covered by snow. And here you see 20-meter resolution Sentinel. Maximum vegetation index. So what is the maximum NDVI that an area reached during the season? You see here that the snowy areas never reach a lot, while the lush heather areas are reaching a lot. We go to another area and you see some swamp or bog areas, really hard to spot again on the aerial photos. But if we're using a potential wetness map based on terrain data and a GIS analysis, it already makes a bit more sense. We combine the both. Almost done. Here we see aerial image again, and this is just an example of the classification results, also to give an idea about the level of detail. So it's not a very coarse Sentinel-based map. We narrowed it a bit more down to the 1 to 5,000 scale that the environmental agency is used to. Here with some reference data in place. It's hard to judge anything if you have to look at this so quickly, but it's looking quite good. We're having some problems in some cases, and that's also my main conclusion. We're getting quite good results on the main nature types that are necessary, but there's a big bottleneck to getting this reference data to calibrate, train, and also to validate this. And an independent field validation is also important. Some of the environmental variables need more testing. So we didn't get all the boxes and inside all of the types, all of the variables ready because we're lacking data, but we see that the system is working and it can be expanded. And that also means that the national product for all of the mountain areas in Norway can be made for the alpine zones. The method can be tested also on open areas in forest. We cannot use exactly the same method, but here also they're already working on different kind of approaches. That is my story. Used a little bit too much time. Sorry for that. The final thing is that we have not been doing this alone. So in Blom, we have been working with this from the remote sensing side, and colleagues in Salier Natur, vegetation ecologists, have been doing the reference data and the evaluation of the products. We got the funding from the Norwegian Environmental Agency. This is a project that we did for 2 years ago, and now we're doing a following up in the province in the center of Norway, in Trøndelag, and the idea is here now to do the final testing, so to see if we can make, as a next step, can make a map for the whole of Norway, but we're not completely there yet. Thank you.